What we're going to look at in this video is rational exponents, or in other words, you're going to start looking at exponents that look like fractions. And what we'll do is we will rewrite radical expressions by using those rational exponents, and we will also simplify and evaluate radical expressions and expressions containing those rational exponents. So we start here with a rational exponent is an exponent that can be expressed as m over n, where m and n are integers, and of course n cannot be equal to 0. And in actuality, radical expressions can be written by using rational exponents. A rational exponent is an exponent that can be expressed again as Rm divided by n, right here. And if we look down here at the examples, you look at your first one, the exponent 1 over n indicates the number of the root. For example, over here I have 16 to the 1/4 power. The n in this expression is the 4. And so when we write it as a radical, the 4 is on the outside as the index. And remember, we don't write the square, but we do write all of the other ones above the square root. And then we would evaluate, we would say the 4th root of 16 equals 2. So right here is what you will look at. Now let's add a numerator here. So let's look over here. We have 8 raised to the 2/3 power. Our m in this case is the 2, and our n is the 3. So remember, going back up here where we had 1 over the n, that nth term. So in this case, the 3, we have a cubed root. So we have the cubed root of 8 squared. And so come over here and write this down. This is the format or the formula that you will use for our rational exponent. So pause the video and write that down, because we will use that as we work through our examples. And this is what I just said, that is the denominator is the index of the radical. So here we go. We have the expression -32 raised to the 3/5 power. And we're going to rewrite it back in radical form. So it's going to look like this. We're going to use 2 types of methods. I'm going to show you the first method here. What we do in method 1 is we actually evaluate the root first. So we would rewrite it as the radical. You see here that the 5th root here, and we're going to raise that to the 3rd power. So what I want to do is, what is the 5th root of -32? What times itself 5 times would give you a -32? Have you guessed it? It's a -2. And then we're going to take that root, and then we're going to raise it to the 3rd power. So -2 to the 3rd power. So -2 times -2 times -2 gives us the -8. And sometimes you might prefer to do it using this second method, and that would be to actually evaluate the power first. So we would set it up. You notice this time, however, that we took this power of 3 and we put it actually under the root itself. So now what you're going to do is you're going to raise the -32 to the 3rd power. And that would give you -32,768. And then you're going to take the fifth root of the negative 32,768. And that would give you a negative 8. So you see that you can approach this in two different methods. You are welcome to choose whichever one you want, whichever one you feel the best about. Let's try another one. We're going to write the expression 64 1/3 in radical form and simplify. So we have, right here, we have that power of 1. So we're just going to put the 64 under the radical of a cube. So here we have the cubed root of 64. So what times itself 3 times would give you a 64? And I hope you said 4. And then if we raise 4 to the first power, then we get just the 4. Maybe you wanted to do method 2, which was to evaluate the power first. So then you would move the power from the outside to the inside. So you would raise 64 to the first power, which of course we know would be the 64, and then you would evaluate it and take the cubed of 64, which would also produce your 4. And let's look at one more. Let's write the expression 4 to the 5/2 power. Let's look at method 1. So we know here that this is the index. So we're actually taking the square root of 4 raised to the 5th power. So we would do the inside first. So we would do, what is the square root of 4? And we know that that's 2, obviously. And then we would raise 2 to the 5th power, and then that would be our 32. Looking at your second method, to evaluate the power first, so we would bring that power to the inside. So we would raise 4 to the 5th power first, which would be 1,024, and then we would take the square root of 1,024, and we have obviously our 32 back. All right. So I want you to now take a look at, we have the radical, but now we're going to rewrite it back as a rational. So remember, this is the index and this is the power. Do you remember that this goes in the denominator? Let's take a look. So there's the nth term, right, to the n power and the m. So this would be 13 to the 4/8 power. We can actually simplify the 4/8 down to a 1/2, and that would be its simplified form. Let's look at the next one. Again, we're going to use that m over n. So remember, 5 is the nth power, so that goes in the denominator, and then 15 is your power that you're raising it to. So then that would give us our m over n, which would be the 15 over the 5, the m over the n. Sorry, my pen's not working very well there. So our m over the n. And then look what we can do with this one. We know that we can take 15 over 5, which is 3, and you can actually go one step further on this one. Well, what is 3 squared? 3 squared is 27. So let's try these. Once you stop the video, try these, and then turn the video back on, and we'll go over the answers. All right, now that you've worked these, let's take a look. We have, as our first one, we have the 4th root, right? And we're raising to a power of 3. So did you choose your m and n correctly? And you would get 81 raised to the 3/4 power. Your second one, hope you got your m and n correctly. Your 3 being the n, and the 9 being your power. Did you go one step further here? Did you take that as 9 divided by 3, giving you 10 to the 3rd power? And then you could then go ahead and simplify that to its 1,000, 10 times 10 times 10. And then our last one, let's look at your m and n values. So it's a 4th root. So that, remember, goes in the denominator. That is the n. And then you are raising that to a power of 2. Did you take this one step further? 5 to the 2/4 can actually be 5 to the 1/2. We're going to leave that one as is because we can't take the square root of 5. All right, so I'm going to give you some worksheets to work on, and you're going to bring those back to class, and then we'll look at these together.